So determining air leakage in our homes help us figure out how to reduce air loss, which is directly tied to very many benefits. This includes comfort, health, moisture control, pest control, and of course, energy utility carbon savings. Currently, our only technology available to do this is things like our blower door tests, smoke sticks, and you could use your hand for the technology, walking around feeling leaks. However, many times this is not always effective, specifically in locating where leaks are, especially during our mid-construction, pre-drywall phases for new construction or gut renovations or additions. So I'm excited to discuss some new technology that's available that might be a little bit less cumbersome than a blower door, but leveraged along with it to help investigate and determine potential air leaks and risks. So before we get started, I want to say a huge thanks to GreenHome Institute sponsor Build Equinox. Traditional energy recovery ventilators, ERVs provide basic ventilation, but often lack protection against airborne threats like seasonal flu and wildfire smoke, as well as typically waste energy. So introducing the SERV, an advanced indoor air quality management system, it offers recovery ventilation along with enhanced protection and intelligent air management, such as continuously monitoring CO2 and VOCs and only ventilating when pollutants reach above desired thresholds. Otherwise, constantly just filtering and recirculating the air to ensure good, healthy air when you don't have those pollutants. It also features a high efficiency heat pump that recovers the heat from exhausted air, preconditioning and dehumidifying that incoming air. Optional UV light if you're very concerned about that. And again, smart technology to help keep out harmful wildfire smoke, outdoor air pollution that has optional VOC sensors for monitoring air quality. So check them out over at buildequinox.com to learn more about the SERV. And do note, for those of you doing Passive House, they have special Passive House calculations now built in for this that we will discuss at a later time. All right, well, welcome everyone to Introduction to Detecting Building Air Leaks with Ultrasonic Tech. This session is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. This course is approved for multiple continuing education units and is specifically approved for three pillars of our certified green home professional designation: health, materials, and energy. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. And check out the 5-digit Passive House code, which you'll receive at the end, as long as you're here the entire CEU approved hour. And make sure to take that survey that pops up to get your information, and we can get you the certificates. So with that, I am excited to hand it to our speakers here today. John Knapp, welcome back to the show. We've had you on before, so glad to have you and see you again. Um, and then we've also got Daniel Dobrowolski. And so welcome to both of you. And at this point, feel free to take it away.
Thank you very much, Brett. Very glad to be here. I'm just going to share the presentation, so bear with me one moment. Okay, hopefully that is now visible to you.
Yes.
So brilliant. So right, I'll start off and I'll pass on to John for a little bit more a little bit later. I'm Daniel Dobrowolski. I work for Tracker Ultrasonics as the head of research. Particularly, I was the lead developer of a project that we did a few years ago now on ultrasonic leak testing. And I'm also the director of the Durham Institute of Research, Development and Invention. First of all, a little bit about us. So we are a UK sovereign high exporting manufacturer of ultrasonic and acoustic instrumentation to customers in over 120 countries. In addition, we provide industry-leading engineering, scientific, and AI services, and we're constantly developing our sensor capability. So we've evolved from acoustics and ultrasound, and do a lot of research now on other forms of sensing, including electromagnetic and mechanical sensors. DIRDI is a research institute based at Durham University in England. It has a partnership with Coltraco Limited, and comprises of over 500 senior academic fellows from a number of universities in Britain, including Oxford, Cambridge, and the London ones too. Um, the point of the institute really, and the reason we explore projects like this, is to combine both what we call Newtonian discovery, so fundamental physics research, as well as Edisonian commercialization, which is research that is more geared towards commercialization and technical application. So the next slide, I'm going to pass over to John.
Thank you, Daniel. I guess my name is John Knapp. I'm the co-founder of Source 2050. As Brett mentioned, we've presented with you before. Source 2050 is a multi-vendor marketplace for high performance and passive house products. Over 600 products from 30 different brands available through one marketplace. And one of the more interesting brands that we have is Coltraco. We are the North American distributor for Coltraco Ultrasonic system. Have been for several years now. And it's been really exciting to bring this technology into the market and see the many uses for it. For this audience, you don't probably need to hear this, but airtightness is crucially important in high performance construction. As you know, that is the key to lowering our operational carbon. If you have a tight building, then you are using your heating and your cooling in its most efficient way, which significantly lowers the energy use and CO2 emissions from the building. It's the keystone to much of what we do. Lowering the loads is the easiest way to lower our draw on the grid and move towards a renewable future. Um, the Also, by sealing the house tightly and controlling when air comes and goes, you're able to exert control over the quality of that air. So for people concerned with indoor air quality, as I think we all should be, it's crucially important to not have that air coming through unwanted leaks and penetrations and failing gaskets and all the rest of it. Um, this, as we learned in the hardest way recently, is also the key to stopping contamination, infections, disease, bacteria, et cetera, coming into the home. Asthma sufferers know well the benefits of living in a passive home and breathing through filtered HVAC, filtered air. And one of the great benefits that we've discovered as passive houses kind of grown in the market, particularly in the cities, is the unwanted noise and pest infiltration. If air is not coming through, noise is not coming through, pests are not coming through. It's an enormous benefit for urban construction. And of course, fire safety. When you've compartmentalized, you can control the flow of oxygen and therefore contain fire much more efficiently. We saw some of those benefits against recent wildfires where tighter sealed, more efficiently built homes survive better in wildfire situations. So all around, crucially important for costs and for lowering carbon and improving health all around. Nothing probably new to this crowd. We jump over to the next. Okay, so typically when we talk about air tightness, I think we're all probably familiar with the blower door. That is still required by most of the certifying bodies, from ResNet to FIAS to PHI. And it measures the air changes per minute, and it will tell you when something is wrong, but it will not tell you what is wrong and where that is and how to fix it. So to do that, how do we find and localize what is causing the blower door failure? The oldest probably method is smoke pencils. Old enough, I've heard stories of people just walking around with lit cigarettes in the old days. But if not that, smoke pencils, seeing where the smoke is being drawn to, is useful, but obviously scattershot. And the bigger the building, the more difficult that is and harder to replicate. Also requires a level of pressurization, so you have to already have a contained, enclosed building for it to be effective. Anemometers can be helpful if you know where the leak is, but a lot of the trouble is finding that leak. There's a problem somewhere. You're not sealed tightly. You don't know where. It's a pinpoint tool that would require you to either know where the leak is or have a ton of patience going inch by inch to identify where it is. And then finally, thermal cameras, which are effective if you have a temperature differential from the inside to the outside, which is not always the case. And also, if you're in mid-construction and it's not fully complete and you're exposed, um, you know, basically useless. So can be very good for thermal bridges and those sorts of things. Again, if you have a temperature differential, but not necessarily the best way to find an air leak. We advance on from there. Um, so with those kind of imperfect tools at hand, what are we looking for a better tool? What would it have to achieve? We really need to be able to quickly assess the airtightness of the building, to be able to do it at any stage of construction. Um, the one of the tremendous downsides of the blower door test is obviously the preparation that's required, sealing everything, closing everything down, uh, usually removing the crews for some period of time, and then just getting that overall binary yes or no without any accuracy as to where the problem is. It's intrusive, it's disruptive, it's expensive if you're hiring someone else to come take it in, to come implement the test, only to find that it's you've not achieved your goal and then have to schedule another one after you've done the work of finding it. So what we want is something that's accurate, something that is easily set up, that can be repeated through different phases of construction, something that has an ambiguous result, right? It's not somewhere there's a problem. It is let us localize exactly where the failures are so we can focus on what remediation is needed. And those really work together. We'll talk a little bit later about how I'm seeing, or we at Source really are seeing people use the technology in the North American market. It can be deployed quickly, repeatedly, each step of the way, for very little cost and with very little time. It doesn't become a whole kind of milestone in the process where you're building towards the blower doors coming, and it's just, hey, let's quickly run a scan, see how we did. And you can do that each step of the way. So I think it represents just a tremendous value beyond these other methods. I'm going to be very happy to dig into that a little bit, but I think Daniel wants to talk to you a little bit about the development of the technology, and then I'll be back in a minute.
Thank you, John. Yeah. So the development of the technology is quite an interesting history. So our company's been around for over 30 years, but an industry which we have been in for that long is in the maritime and naval sectors. And watertight integrity is a really important factor in that, and we've developed technologies for that for years and years and years. It was 2020 really when we thought about applying this to airtightness. We were given a grant by the UK government for trying to do something in terms of research and development that would help mitigate the spread of COVID-19 in hospitals. And so, in a sort of frenzied 9-month period, we devoted some resource to this. We discovered that actually it was possible to quantify leakage size ultrasonically in terms of air leaks. And we deployed this for hospital wards where it's important for airborne diseases to pressurize these facilities. Often they're negative pressurized, but sometimes you have positive pressurization. And in order to achieve that and maintain it, you need to ensure that a sort of maximum threshold of air permeability is not exceeded. So we developed this technology, and then we very quickly recognized that if you can do it in hospitals, you can do it in any building, and actually the applications beyond the spread of disease are huge. So the ultrasonic airtightness tester that we developed actually ended up being an instrument that gave people confidence to find, fix, and seal the air leaks that they had with pinpoint accuracy, providing those insights that allow you the certainty to manage building airtightness simply and quickly. As a result of this research work, actually, we were invited to be on the Innovate UK's Net Zero Heat cohort, which is a group of innovative companies in the UK who are gearing towards net zero. and producing technologies to that end. And it's been a great honor to sit on that panel. Back over to you, John.
Great, thank you. So yeah, so how does this work? What is the product itself? So as you can see here, these are the parts that would be in your unit as it arrives, and I kind of walk through what each one does. Um, Taking a step back, what we're talking about is essentially a speaker and a microphone. And I know, obviously, from Daniel, this is a very you have an understanding of this is sophisticated technology that is the product of years and years in research. But I also tried to bring it down to a very kind of intuitive process. There's a speaker that's going to be outside, that's blanketing the exterior of the building in ultrasound, and that is generated by this device here in the bottom right that the cursor is circling. This is the size of an iPhone, a little bit thicker, a little bit smaller as far as the length and height, but as light, maybe lighter than an iPhone. So really simple to place. At the top, you'll see the tripod that comes with it that allows you to mount it on the ground. It also can be attached to scaffolding. It could be lowered down from up on the roof. It can potentially be mounted on drones. We could talk about that later. But the idea is to have this outside the building positioned in a way it projects like a movie projector would. So the further back you are, the further it casts, the more of the surface of the exterior it's covering. It comes with a placement guide that shows you exactly how far back you can be to stay within the intensity range that you need to be to cover as much of the building as you can as possible, and obviously super easy to reposition as you move around from one area to the next. So that is now blanketing the exterior with sound, with ultrasound. You, meanwhile, are on the inside, and you're on the inside. Typically, that's not always the case. We'll talk about scenarios where you want to reverse the two, but the typical application is the generator's outside, blanketing the exterior, and you are inside with the heart of this, which is this microphone that's at the end of this probe, the wand here, that is attached to this tablet. The tablet here has a touch screen on it. The touch screen allows you to take a photograph to actually image the area that you were testing. And then you approach the wall with that microphone. That microphone is simply detecting any sound that's getting through. If any sound is getting through, that means air is getting through. Ultrasound will find leaks down to a few microns. Daniel can tell you the specifics of it, but it will find the smallest leak. It'll also find convoluted leaks. It'll travel. It doesn't have to be a line of sight kind of a leak. It could be something where it's a penetration, in the sill plate that's coming up the wall, and you're hearing it through an electrical socket on the interior. You'll be able to identify that. So it really can travel within a convoluted path. But if there is ultrasound getting through, there is a path for air to get through. It's really that simple. You detect it from a fair distance. I analogize it to if you've ever used a metal detector. You start at a bit of a distance until you start to see some interference. You can see on the screen here this meter, which shows you the level of activity, if any, that it's detecting. So you can do a scan, and there's as much art to it as science. After you've used it a while, you get a sense, and you all, I'm sure, have an idea of where your leaks typically are. So around your windows, around your hardware of your doors, around the sill plate, around ducting, any MEP penetrations, these types of areas where you typically have issues or where you'd want to start looking. You can start at a good distance, and then you start to see a little activity. You come in a little bit closer, and you really can pinpoint down to where the leak is. So simply as a diagnostic tool, just is there a leak? This is fantastic. It goes further than that. There's the ability to actually measure, to quantify the leak that's there. But by using again, this is a good Daniel question more than for me, but by using an algorithm that anticipates that measures the percentage of saturation that's coming through, the percentage of sound that's coming through, they are able to use an algorithm to simulate what the actual airflow would be, what the CFM would be for that space. So you go into this kind of quantitative mode where you can scan over the leak, measure the size of it, the airflow that's coming through, and then pull that together into a CFM measurement for that condition. You further later can then pull all of the CFM measurements that you've taken in a space together, put in some additional information like total square footage, air volume, wall thickness, wall material, et cetera, and actually get to a simulated ACH. You get, sorry, yeah, air changes per minute, air changes per hour, ACH, as you would with a blower door. So it is a fantastic tool simply for diagnosing. We know there's a problem somewhere. Let's go find it. And the binary, is there a leak or not, is answered really quickly on the screen. When you want to actually quantify, what is of the various leaks that I found, which is not the situation you want to be in. But if you found a dozen leaks and you have to prioritize which ones are you going to seal first, having the CFM measurements at the different conditions is a really great tool to be able to say, these are the real culprits. We've got some racking in these windows, the gaskets have failed, there's a problem with the sill plate with gasket, whatever it is, you can really zero in on those first. And fix those first, and then redo your testing, and then go back into the smaller ones if you're still not where you want to be. So it's a really fantastic tool. You also have headphones here, which you can use if it's a noisy environment or a bright environment and you don't think you'll have a good read off of the screen. That really gives you sort of the metal detector experience. Okay, we can move on to the yeah. Good.
So, what about someone who's trying to look at that leakage coming from the exterior if they're doing, exterior rigid insulation and they're trying to air seal out there. Can you reverse the process?
Yeah, you absolutely can. There's a number of cases we could talk about where you would want to put the generator inside, be blanking the interior of the wall with the ultrasound, and be outside with the microphone, with the sensor,
Yeah.
and seeing where that's penetrating. Particularly the sort of convoluted pass I was describing, where you can see some sound is coming through a power outlet, for example, on the interior. But obviously, right behind that, there's just rigid. That it's not right behind it. You then can set up the generator on the inside, facing that wall socket, and then go on the outside and see, well, where is this actually coming from? And see, oh, I see, like 6 inches down, there's a failure in the sill plate. So they're not aligned, but there's some really good uses. Attics as well, if you want to be up on the roof and you want the sound coming up, from below. There's a number of really good use cases for flipping it around.
Now, what about raters do duct leakage, right? For Energy Star, for green programs, code. Obviously, you're looking at mastic and sealants. Some of them are hidden behind the walls. Is that something that could be useful there?
Yes. So the results of the testing are not yet accepted by these kinds of agencies. That's a
Oh,
project for us.
let me
Yes.
sorry,
Yeah.
let
Yeah.
me set aside I was just kind of laying why would someone would do it, but setting aside that part of it, just from a technological standpoint, could you try to determine duct leakage in the same way?
Duct leakage, you absolutely could. Yeah. I think there's a process for that as well. If the generator is in the inside of the duct, and then you are on the outside, you'll be able to detect if the sound is coming out of the ductwork. Yeah.
Yeah.
Great. Yeah, and keep the kind of questions coming. We want to have a nice full kind of Q&A towards the end. If you want to not disrupt, if you want to interrupt or interject while we're speaking, happy to pause as well and make this more conversational. But feel free to just throw them in the chat, and we'll be sure to have time at the end to go through all of them. As you can tell, between me and Daniel, there's more technical things that I'd probably have Daniel answer, and more practical things in the field that I would jump on, just what I've seen how I've seen people using it in the field. Okay, yeah. So I think this is a little animation of the process I just described, where the generator's on the outside, and you are listening on the inside. If you're using the headphones, that's the experience. If you're just using the visual, you see it on the screen. The level increases as the leak becomes more severe. Okay, on to the next. Okay, and so this is a video demonstration we did. I did with Kevin Brennan, who some of you may know. He was a past spouse instructor and man about town in these areas, where he was working on a project in Manhattan. And I just did a quick walkthrough just to show you kind of real world what this looks like. So we'll just let this play. It's only about 2 minutes.
Hi, my name is John Knapp. I'm the co-founder of Source 2050. We're here on 25th Street in Manhattan. Great project that's underway. It's a firehouse retrofit to a single family home. And I'm here looking at the Coltraco ultrasonic porta scanner today. It's an air tightness detection device that works off of ultrasonic frequencies. We have a transmitter that's just through the window here, which we've set outside, that's transmitting ultrasonic waves through the back of this house. And I have here a scanner that's detecting if any of those are getting through the wall. So it allows us to detect whether there's any gaps in the air tightness barrier that need to be remediated. So I've been scanning through with Kevin and found nothing. As we were coming around the door, everything is nice and tight, but I got to this spot right here where I started to see some activity, some red and green popping through the bottom of the meter. So I talked to Kevin. I said, what could that possibly be? And it looks like it's simply that we have some masking tape in here to protect the door frame, and that the gaskets are not thrown on the door, so it's not fully tight. So Kevin tightened up the door. I redetected it. It's airtight. Although the entire signal has gone away. So it's a really nice test case of the sensitivity of the meter. But I was talking to Kevin, like, if this had not been that easy to fix, if it had been somewhere else in the attic or something else, how would this been useful to you? And if we detected it in the system, it'd be easy to mark that off and then throw the crew and bring in some foam.
Take a shape, take a Sharpie, mark where it is, and then fix it and tape it.
Great.
Find the leak, seal the leak, fix the leak.
Great. Yeah.
And then test it again, make sure it's sealed.
Yeah, yeah. And you can see that you're able to take a picture of every wall that you scan and then mark it up with where you detected the leaks. And then as they're remediated, you can remove them. As Kevin said, if you've really got your air sealing crew on your elbow, you can also just mark up where it needs to be, and you can do a whole room, and they can come through and then seal where they need to seal. So it's pretty interesting. Instead of walking around with smoke pencils and fog machines and trying to track where things are going, you get a pretty crystal clear image of where there's any weaknesses in the air barrier.
Cool.
Great. So just to wrap up, a quick comment on the video, and then Daniel will take you through the research they've been doing in the UK. I joked around. I was nervous about using that as a test case because Kevin, if you know Kevin, he is known to be absolutely meticulous in his air tightness and air sealing. So I was wondering if we were even going to have something to demonstrate it, because his buildings are typically so tight. And luckily, we just simply had that he had some masking tape across the hardware so that the hardware wouldn't throw on that door, which presented the issue. Which was obviously easy to remediate. It's different than if the membrane wasn't hung properly or terminated properly, or the door had some racking on it. It would be a more involved remedy, but it wound up being a really good demonstrative for us, because as you can see, as soon as I went down the door, there was a massive problem right around the hardware, and it was simply taking the masking tape off, allowing it to fully engage the gaskets, and then it was resolved. So pretty simple solve there, but also a really good demonstration for how quickly it was able to detect that problem. Okay. Over to you, Daniel.
Thank you, John. Yeah, so following the development of the technology, we've undertaken a little bit more research, and we've partnered with an institution in the UK called Leeds Beckett University, which is a university that really focuses on building sustainability. They've got a big building sustainability center there, and Professor David Johnston, we've now been collaborating with for a few years. When we spoke to him initially, he said that the airtightness performance of building fabric can have a significant impact on energy use and CO2 emissions, as we know. But really what he was trying to focus on was the need to bring in new tools, especially ones that are realistically affordable, from the research environment to the real world environment, that can capably assess air tightness and performance rapidly. And that's really where our device came in, and ultrasonic testing in particular. So we've conducted a number of tests, and this is just to give you an indication of part of the scientific report that was generated. We have on the left a report. This is automatically generated by the ultrasonic instrument. And on the right, we have some comparison to thermographic images. So this is a simple door which is installed to a very airtight spec. So there's four different leakage points that were picked up ultrasonically, and these are marked on the photograph. And they are then numbered here in this table below, and the cross-sectional area, that's the in square millimeters in this case, but equally can be reported in inches. Those are calculated automatically by the device. The airflow rate is also calculated automatically given a pressure differential which the user inputs. So you can see not only the location of those leaks, but also their relative severity. And you can see that leak number 4, for example, which is down right at the bottom, is much larger than these two leaks in the middle, which are actually just the keyholes. And then if we compare that to the thermographic imagery, we can see that it does match up. So you can see the top and the bottom, that there's some darker spots. However, it's not completely clear, and you can also see this dark line around the edge of the window, and we think that's probably thermal bridging because there's clearly no air leak or any air that's flowing in between that glass panel and the edge of the door. So that just demonstrates that you can identify air leaks thermographically, and they do match up with ultrasonic tests, but it's a little bit unclear as to which are just thermal bridging and which are air leakage. The study itself occurred in 3 different environments. So we had a controlled environment, which was essentially a recording studio broken up by a dividing wall. And we took out part of that wall and replaced it with a double ply layer, and then introduced our own very specifically sized leaks. So this was a very controlled environment. It was relatively airtight. The idea was to sort of control the size of the leaks and then measure them, and to just check that we know exactly how big they are. Actually, is the device quantifying them in an accurate way? The second set of tests we did was in a partially controlled environment, which I'll show you on another slide, but that was essentially a full passive house property that had been built within a university facility, this big building which had climate control capabilities in it. And then the third was a number of uncontrolled real-world environment tests, so a number of different properties and buildings. We undertook pressurization with 2 different devices. The first one was a blower door, and the second one was a pulse test, which is a much lower pressure unit, and it's a sort of instantaneous test. And we also compared the ultrasonic testing with comparative data from a streamer flow hot wire lattice anemometer and the flow hood and a thermographic camera. So these were the results in the controlled environment. And the thing that immediately jumps out is that there's a clear trend with the ultrasonic tests, but the other tests were all a little bit all over the place. Now this is it was sort of unexpected at first, but then we realized that actually in this environment, it really should be expected, because what this is comparing is the equivalent leakage area as determined with the blower door and the pulse test method. And we're comparing that to the airflow that is measurable through some very small leaks. And these leaks are with a hole diameter of 2 millimeters all the way up to sort of 12 millimeters. So if you imagine within a whole room, a singular leakage point is well within the error capability of a blower door. So the air permeability, or the CFM that's going to be reported by a blower door test, is typically much larger than one single leak is not going to make a large difference. So even the bigger leaks in this range didn't have a noticeable, we couldn't really track that the equivalent leakage area had increased noticeably because of those larger leaks. But we could do that ultrasonically. What that means is that ultrasonically we can identify much smaller leaks, and we can also quantify them very accurately. And you'll see this column here, the true leakage area, matches up quite nicely with the results gathered with the ultrasonic testing. Moving on to the partially controlled environment tests. This was at a place called the Salford Energy House at the University of Salford. The purpose of this was to compare ultrasonic testing with blower door and thermographic tests together. So while the ultrasonic testing was going on, we were also pressurizing the space, and there was a thermal differential. And these were done blind. So we had the professor and some of his research staff doing the thermography. Meanwhile, myself and a colleague were doing some ultrasonic tests. And what we found is that when the results were ultimately compared, the thermography identified significant direct and indirect leaks, so hatches, ventilators, doors, and ceiling voids. But there were limitations in terms of the quantification and exactly how to interpret between the leaks and the thermal bridging. The ultrasonic testing found and quantified all of the direct leaks as well, including notably the trickle ventilators and leaks in and around doors. The ceiling voids were a little bit more difficult to pick up ultrasonically, but the air permeability that was derived from the ultrasonic tests matched with the blower door tests. The direct leaks that were picked up also matched, and the ultrasonic instrument was able to provide additional flow rate data associated with each leak. The final point is that because we had to install the blower door on one of the doors, we weren't actually that door wasn't actually able to be tested thermographically. So once the blower door kit had been taken away and the door had been reinstalled, we were then able to identify that there are some significant leaks around that door ultrasonically. So that's just one thing to bear in mind, that there is a use there as well. Moving on to the real world tests. So we've now done the partially controlled test. We're moving on to real properties, and there were a number of different buildings that we tested, including one that was currently under construction. So that was a high school in Edinburgh, and this was a high school built to passive house standards, against a very high standard of air permeability. But it's a very large building, so actually quite difficult to pressurize a large building in order to do a blower door test. So what they did was they sectioned off different parts of that big space using a sort of medium density fiberboard placed across a space to compartmentalize it into a smaller area, and then pressurize that space and identify the leakage going out into the outside world. The challenge with doing that, though, is that you don't know exactly how airtight that artificially constructed layer is. And so the ultrasonic device was very useful for that, because they could install that division, go around with the ultrasonic test and find if there were any leaks that needed to be sealed with masking tape before they then did the pressurization. So that was quite an interesting study. We also tested, you can see these top three images, a number of dwellings. These were made of a novel sustainable building material involving straw, again built to passive house, but they'd been built, I think it was about 5 to 10 years before. So while they were built to a certain spec, over time, some of them had developed leaks that meant that their overall air permeability had increased. So we were able to identify those leaks using the ultrasonic tech, and that was also written up into the report. So provided an interesting case study about what happens post-build, and there are people living in these properties, so being able to do a test non-invasively and non-destructively is quite useful. Then finally, in the bottom right, we have an old church, which when originally built would have almost certainly been extremely susceptible to drafts of air in and out. But this had been retrofitted. And it was in the very last stages of retrofitting for, again, passive house standard. And one interesting thing to draw out of this study was that these skylights here coming out of the roof are supposed to be extremely airtight. But after they had been installed, there was some wiring that had been run along the inside of those windows, and it was close enough to the seal that although it wasn't visually clear that had disrupted the seal. In fact, where the wiring went too close to the seal, it had actually led to some air inflow getting through there. So we were able to pick that up ultrasonically, which meant that the wiring had to be adjusted and the seal could be returned to its non-compromised state. So ultimately, this has led to a published paper. We've got another one in the works as well for a journal article. But this was for a conference, the Build Air Symposium in Germany. And the sort of headline finding is that ultrasonic air tightness quantification consistently measured within plus or minus 10% of the actual leakage area of all of the known leaks that we were testing. And even very small leaks could be accurately measured. So we can detect leaks as small as 0.06 millimeters, which is the thickness of a human hair. And we can quantify them, at least we've tested it down to 0.5 millimeters in diameter. So ultrasound also can excel in identifying problem areas that traditional tests might overlook or fail to quantify. Back over to John.
Thank you, Daniel. Yeah. So as I said, we've sort of been in the front seat here. It's been really exciting to bring Cultraco into the North American market. And what that's allowed us to see is really just the incredible diversity of use cases that people have found for it. I think when we started our conversation, I assumed this would be an absolute dream for your passive house consultants, because this is the perfect way to prepare for the blower door test, and then to see if there are problems, to pinpoint where those are so that you can quickly remediate them. And that is certainly one of the use cases, and we'll come back to that in a minute. But what's been really exciting from my perspective is to see all along the chain, of from production down to verification, the many uses that people have found for this technology. We see here a testimonial that we actually got from the Signature Building Systems. It's a modular company in Pennsylvania that's doing really, really incredible work. They did this project in the Bronx. Is how we found out about them. We did the testing for them, and they wound up incorporating the technology into their actual factory. So they are now using it, but as the boxes are completed in the factory, they used to subject them to kind of ad hoc blower door, very time consuming, and not accurate as to where there is a failure. They're able to do that, right there as they're being loaded onto trucks as a final QA, and then again after install. We have the same story with window manufacturers that have started using the technology, that purchased it from us. They used to install each window in a mock-up room, run a blower door to do their final Q&A. They're now able to do that, with it just standing there, and they're able to use the ultrasound to check the glazing and the framing and all the rest of it as well is done well. And then on to install, where you also have the installers using it now, that whether it's modular panels or windows that are being shipped and then installed. You can take that test right after the installation is done, so it's very clear, what was the state of things when the installer was finished versus what might have happened later. Which is a perennial question on these kind of projects. If there's a problem later, where did it begin? You have a snapshot of what everything looked like as far as its tightness when the installation was completed. And then on down to contractors using it both to double check the installers. But for example, when the MEP penetrations are done, even holding the subs on site until they run the scan to make sure that the MEP penetrations were actually sealed, run the quick scan to make sure that everything is tight before they've gone home, and now you're chasing them down or figuring out a way to fix it yourself. Kind of allows for a collaborative. It's definitely kind of a CYA tool, but also very collaborative, because there's no guessing, there's no finger pointing. It's just like, here's what it is, right? We're looking at a problem. We're looking at the image on the screen. This is our measurement. There's an issue here. Let's go and fix it. And most importantly, let's fix it when we found it, when we still have access to it, right? Before the drywall has gone up, before the installation is put in. So many of these last minute blower door failures are you're pulling your hair out, because you may have a sense that something's gone wrong under here, but you start having to pull out drywall and insulation to get back to where the problem was, the sill plate or where penetration was or whatever it is, you're seeing it right then and there. When you still have access to the space where you can do the quick fix and save yourself the headache down the road. Again, it's so easy to set up, and it's part of the learning curve is like this isn't a blower door. This doesn't take hours to set up and cap everything and shut everything down. And this is a matter of minutes. Just let me check this quick before you head out of here for the day. Make sure that your work is sealed up tight. So really fantastic tool for that. And then on down to the consultants, the verifiers. If you're working with ResNet or you're doing evaluations of existing buildings, very useful to really pinpoint where the problem is. A lot of the conversations, when you have a low measurement on an existing home and you want to raise your score, these are typically the problems, the windows, and you kind of go through your list, but you're not actually able to say what the problems are. And you have situations where the windows are fine. They were just installed, terribly. And, it's a beautiful window installed, within, 2 inches of uninsulated space. So this is a tool that allows you to identify that. You don't actually have to replace your windows. We just have to pull back the drywall there and get some insulation in there and seal that window up properly, and you'll be fine. So it just introduces transparency to those conversations, less guesswork, maybe this will work, let's try this, let's try that. It's like, here's what the problem is, let's go in and fix it. So it's been, as I said, really, really exciting to see. It's not just a consultant's tool. It's not just the, where did something go wrong? Diagnostic tool. It's something that's just on, in your tool belt through every step of the process that really is invaluable for opening the conversation, being more transparent about where issues may arise, making sure you fix them quickly and cheaply when they arise, instead of having this guessing game at the end. So Mike at Signature Building was nice enough to give us a testimonial. We have a number of other people in the field that are using it, that are really excited about it. We're going to start pulling those together as well. And a lot of questions I get are, is somebody doing what I'm doing that I could talk to, or do you have testimonials from somebody in this space? And we are working on kind of pulling that together, because we have a good number of people out in the field using it now. But I'm also always happy to talk with people through those questions and even do a video demonstration. So yeah, I think that's the real world results piece. Daniel, do you have another slide before we move into the Q&A? I think you might have. Yeah. Yes, you do.
Yeah, that's right. So just to give you an example of a project where not using an ultrasonic technology could actually led to a lot of extra cost and delays, and I think this is actually quite common if you're trying to do a new build or a retrofit that needs to meet a certain standard, but you're actually doing it blind because you don't know where the leaks are. This is an archetypical example of how that can go wrong. So this is a case study by the Passive House Institute in Bavaria in Germany. It's a moderately sized dwelling that was retrofitted to Passive House standards, and it required 3 different remediation cycles in order to finally meet that standard. So all of the kind of basic things were done, where you had more insulation installed, new components, etc., etc. But when it came to the blower door test, it failed. And so they were attempting to remediate this, but they didn't use ultrasonic technology. And so they weren't able to guarantee that those remedial measures were even in the right place, let alone effective. And so 3 cycles occurred, and we calculated that as $30,000 of avoidable cost just from this small building. And so really the purchase of an ultrasonic instrument pays itself back many times over just with a single building. Now imagine that you're using that for multiple buildings, and the cost saving elements are quite clear. Add to that the energy efficiency savings as well, and it's a case that can be very easily made for the importance of ultrasonic instrumentation. And that's on to our final slide, so we can answer some of the questions.
Yeah, great. Thank you, Danielle and John. And we have some time for questions. We have some questions coming in. Before those questions come in, or before we get to them, a quick reminder that yes, this session is being recorded. We will have it posted in the next couple of days. You can check our YouTube channel there, or you can go there right now, click subscribe, ring the notification bell. You'll get an instant update when it is available on there. For those of you watching this in the future, not right now, but on demand, take your quiz with an 80% passing rate to receive your continuing ed certificates. But those of you here live, as long as you've been here for the CU hour based on our policy, you can review that. Take the survey that pops up. We'd love to hear your feedback, whether you need CEUs or not. Put in your AIA number there and check your spam for certs at gutenbergcerts.com to receive your certificate. You can log into your account, see it there. And as always, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our nearly 500 members. We're so close. We're trying to get there for our 25-year anniversary celebration. So if you haven't subscribed yet, supported us, go check it out. And a huge thanks to our sponsors who are helping us decarbonize, such as Rheem for heat pump water heaters, Build Equinox, Architectural Resource for more sustainable design, Panasonic, Timber HP, Tamarack, thanks to their support and everything they do. So I see a lot of questions and I want to try to kind of get through some of the simpler ones. Forgive me if you don't like that term on your question, but I'd say some of the more simpler question and then kind of get into some of the more complex questions. And thankfully they're kind of in order from that range. But um, one of them was, I think, going back to maybe the video, John. Maybe that's what it was, or maybe it was something else. But he was saying, how specifically did you repair the leaks in the new door weather strip as shown in one of the examples? So maybe the question is, how does this technology, did it help you, make that repair?
Sure. Well, that in that example with Kevin, as I said, that was simply that
Mm,
he had some
mm,
tape across the hardware, so it wouldn't engage because they were going in and out of it. It was a live construction project, so that was just taking the tape off and then allowing the hardware to engage, and then the
mm,
gaskets engaged, and we were totally tight. In a different situation, if it had been a door that was hung in properly and you had racking, you'd be able to see that because you would see the leaks really intense in, let's say, the
mm,
bottom right and the top left corner. And you
mm,
kind of get a sense of the geometry of what was going wrong. So that might be taking it off its hinges or
mm,
rehanging it, that sort of thing. If it was that it was not racked, it was installed properly, but the actual framing wasn't installed
mm,
properly. There was an insulation between the framing and the wall, rough opening, that
mm,
type of thing. You might be getting in there with some spray foam or some additional batting, depending on what you're using in that process. So the remediation is going to depend on the location of the leak and the rest of the
mm.
project materials.
Yeah. Um, And the next question, and I think you talked a little bit about the windows, but maybe go into some more detail here. Specifically, the question is when using a blower door on casement windows, this individual typically does positive and negative pressure tests, which helps them understand how the windows will handle strong winds. Does this ultrasonic test offer anything comparable?
So it's used really in whatever the existing pressurization is typically,
Mm,
but it certainly can be used with pressurization. You could
mm,
prepare the building, as if you were doing a blower door test, and introduce pressurization, and that's helpful. Often you've got again, kind of gaskets that engage or
mm,
disengage depending on the pressure on the inside or the outside. If you're taking it with zero pressure and everything is just sort of lax, then there won't be airflow. Where there may well be airflow if they're engaged and there's pressure against it, or they may be disengaged if there's so much pressure that they're being pushed off, beyond their tolerances, that sort of thing. So you certainly can introduce pressurization if that's your concern, and then use the test just as you normally would. So
mm.
you certainly can be inside or outside, doing the test as you normally would after you've introduced pressure, if that's a concern.
And to kind of add to the fenestrations, windows and doors conversation a little bit, the question here was, could the unit be used to test these when I guess as they're installed. So adjacent empty rough openings or neighboring windows and doors are not yet installed. Allow so much sound leakage that the test could not be valid. Could we do a mock-up? Just those are some of the questions there. So.
Yeah, you absolutely can, because it's very directional. The blanket is sort of out here, but what you're listening for is kind of
Mm,
unidirectional. So you're not going to catch a lot of interference kind of coming
mhm,
around. I think Shannon, on my team from Source 2050, is somewhere in here. I did a demonstration on one of her projects in Pennsylvania where
mm,
the back of the house was missing. They installed the window, but we were basically standing outside. But they wanted to test the window install, and that worked perfectly. We set it up
mm,
outside. We stood inside just as you normally would. There was no interference, coming from the sound coming around. It's pretty directional in that way. So you absolutely can be doing it mid construction.
mhm.
Yeah,
Now
it's
oh,
also
go ahead.
sorry, it's also worth noting on that the generator, the speaker, if you will, producing the ultrasound can
Mm,
be placed in different configurations that suit your space, and there's also an adjustable power to it. So if you're looking to test a really specific area and you don't want to flood your space with ultrasound, you can reduce that ultrasound output and
mm,
place it closer to the area so that you're not going to have any risk of interference. Um, if you're interested in surveying a much larger area and pumping out as much as possible, then you can place it further back and up the amplitude.
Well, and I'm glad you brought that up because that was going to be one of my questions because I kind of, see you wandering around looking at everything individually. Couldn't there be like a large sort of receiver device that's set down and it just scans the whole wall like automatically and it's just boom, boom, here they are, and then you just turn it, right? Like, could that happen?
Yeah, so I mean the way it works currently is that it is directional. So as John
Mhm.
explained at the start, it's a bit like a metal detector. You can pick things up
Mm,
from a distance,
mm,
but it very much relies on the wand being pointed in the right direction.
yeah.
Then as you move closer, it will become apparent exactly where that is.
Mm,
What you're asking there is more like an acoustic camera, the idea of sort of taking an
mm,
acoustic image of a whole space.
yeah.
Um, that is something that I think
Mm,
there's been a little bit of research on, but
mhm,
just in terms of hardware, uh, you can't do that
mm,
with a single piezoelectric component. You need a whole array
mm,
of different receiving elements to piece that image
mm,
together of what's going on. So it's something we've looked at, but it's
mm,
just in terms of the cost of the unit, you're likely to see a much more expensive piece of kit. So we're not sure that the market is
mhm.
available for that at this stage.
Yeah. And speaking, there's a lot of questions here about costs, someone trying to infer as to whether, when you're selling it, you kind of get all of the things that were shown with the device. So is that, coming with everything? So is it the question was, does it come with the tablet? Yeah,
Yeah.
or are these sort of add-on features?
Yeah, so
Yeah.
the answer is yeah, it comes with the tablet and yeah, John, go ahead.
No, no, yeah. There's two there. I was reading the chat as well. I think there's two different models available on
Mhm.
Source 2050, and generally there's the ultrasound portal scanner that we really focused on today, which is sort of the full unit that it does the imaging,
Mhm.
allows you to do the quantification, all the other features. There is a scaled down
Mhm.
version that's just the Porter scanner where there's no screen, there's no quantification at all. It's using the same underlying technology. Daniel,
Mhm.
correct me if that's not accurate, but it's just as precise as far as detecting the leak, but it's not going to quantify it. It's really just going to give you kind of that meter reading. It's a much smaller unit. Um, and that's effective for if you just want to know, is there a leak or isn't there?
Mhm.
And some comparison, some ability to compare within one particular condition. So if you're looking at a door, if there's a
Mhm.
hardware versus the hinge versus racking versus gasket fail versus brush strip missing, all that sort of thing, you'll be able to
Mhm.
see within that condition what's the worst area versus the others. But it doesn't allow you to then translate, compare that to when you go to the next room and there's a problem with the window. It's sort of you're resetting the comparison. So it's not possible later to say, among all the places that we
Mhm.
checked today, this was the most versus the other. It's think of it more as just like a binary: is there a leak or isn't there? and the relative strength of the leaks that I'm looking at in that particular condition. So it's a much
Yeah.
scaled down unit. The cost reflects that as well. It's substantially
Right.
less, but it
Right.
doesn't allow you to image it. And one thing we didn't dig into too much, but we could do at another time or on a side is when all those images are recorded and kept and filed, so you get a PDF report out of this, which is incredible for documentation. If you're doing a multifamily and you're doing a diagnostic, you can do, the building address, third floor, unit number, south wall, window, and organize. So when you're done, you've got photographs of everything that you've imaged with the locations and the measurements of the leaks that you found there, all organized together, which is a really great tool for the before. And then you go in and do your remediation, then you can redo all of those images and then compare after. So it allows you for this incredible documentation that's really useful for a lot of applications that the smaller unit just doesn't have. It's really just real time. Is there a leak or not? Daniel, do you want to add anything to that description of the difference?
Just to say that the signal processing in the unit that comes with the tablet is a lot more sophisticated. So that's what enables it to quantify the size of the leak. It's more stable. There's a different way of averaging the signal. But ultimately, if you're just interested in finding where they are, the standard unit, the cheaper unit, will do a great job of that. But if you want any idea of whether it's a big leak or a small leak, you can rely on the what's called the Porter-Scan Airtight, which is the unit. It's the unit that's really designed for that.
Yeah. And it does seem, I guess if you're trying to move quickly, you're really talking about a second person outside, or as you mentioned, John, a drone you can control. Would that be accurate to say?
It's always easier to have more hands, but
Right.
I've done any number of demonstrations on my own. It's really not terrible. I think, and that actually dovetails with another question I see in the chat, which is what distance and how do you place the generator? There's a document that comes with it that kind of gives you that instruction.
Yeah.
I said, think of it as a projector with a throw. If you're really up close, it's going to be very intense, but a very small throw. The further back you move, the wider it's going to cast, the more area it's going to cover. And all of the specific measurements, like what distance will give you what throw. That's all. You have a document that comes with it, and it's also, after you've done it a few times, it gets pretty intuitive. How far back do you have to be? So if you're by yourself, it's not terrible to go out, set it on a tripod. You're going to be covering, the entire first floor, which is going to be 2 or 3 windows, over 2 rooms or whatever it is. And then you go back inside, you finish all that up yourself, and then you're ready to move on. You go back outside and reposition it. It's not terrible. It's not always easier to have somebody out there. But I've done it plenty of times on my own.
Yeah. Well, and that gets into, I think, a lot of the questions, about training. And so I think the first question is just what other kind of training, either virtual, asynchronously, or in person, or virtually together, or even going beyond training, are you looking to certify people to say, just like we certify people usually with BPI for blower door, is that something that is coming down the line?
So Daniel can talk about other efforts. There's no formal training process currently, but there is a tremendous amount of support from the Culture Echo team in the UK, as well as from Source 2050. What we often encourage people to do is watch all the videos that we have, familiarize themselves with the process, get the unit, play around with it for a few days. A lot of it kind of is pretty intuitive, but then develop your questions. And then if you have them, we'll schedule a call and we'll have Daniel or other people from the team in the UK join. And we love to support and learn. As I said, part of this has been really exciting for us to just see how people are using it. There's a lot of the expected use cases that we're seeing, but also we hear all the time of people that are using it in ways we had not considered before. So that's super useful to us. So it's we're very hands-on about that, and the support is fantastic, throughout the process. And Daniel, do you want to talk any more about training? Yeah, go ahead.
Yeah, I will say that we do offer our own certification, so it'd be great, and it's something we're hoping to be supported by some bodies in the US, but at the moment we have our own Coltraco certification that we offer relatively cheaply. So if you want that kind of stamp of approval, we can do the training it's a sort of virtual training, um, and you get that certificate to say that you're competent to use the technology.
And do you list out then if someone's like, I'm looking for folks who are certified, I can kind of cross-reference that just like a certified rater. Is that something you do online?
It's not something we do directly at
Okay.
Coltraco, but it's quite a good idea. It might be something that we should
It's all
do.
yours.
Yeah.
Well, and is that training uh, in person? Is it virtual? Is it asynchronously? Is that at the same time? How does that work? Or all the above?
Yeah, so synchronized virtual training
Okay.
is what we offer.
Mhm.
And I think sometimes John's done a few visits in person,
Yeah.
but yeah, there's if there's a convenient way we can arrange that
Right.
that sort of thing, then it might be possible as well.
So for you, those of you in the US, that's probably in the morning because you're getting into your evening right now. I know you need to get going there soon. But do you all have time to stick around for a couple more questions, or do you, John?
I've got a few minutes.
Okay.
I've got to bounce in a bit, but I mean I can see one which I can partially answer about wildlife and dogs.
Yeah, yeah, yeah. Think about our animal friends getting affected by this. Is that a concern at all by the sound emissions?
Ye- Yeah, so we've not done a formal sort of study on this,
Yeah.
but the generator produces ultrasound of a 40 kilohertz, so that is within the
Mhm.
range of the hearing of dogs. I think they
Mhm.
go up to about 60 kilohertz. Um, Bats as well can
Mhm.
probably hear this. I've used the device in the vicinity of a dog, and he didn't really pay any attention whatsoever. But
Mhm.
yeah, it's not something we can formally say either way. But there are some animals which would be able to hear the noise.
Mhm.
Yeah, and
Fair
I would
enough.
add just anecdotally, this actually
Mhm.
the same project I mentioned before in Pennsylvania with Shannon. The owners had dogs kind of running the property while I was doing the test, and they did not seem to be adversely affected by it. But that's just anecdotal.
Sure.
Mhm.
Well, and again, so going back to the reason about the training to kind of next to jump into the next thought is, you show us all this data that it could, I guess, in some ways, maybe be careful with the term, but I'll just say it, replace a blower door. I mean, a blower door is not fun to lug around. It's very expensive, and especially in the existing housing market, there could be asbestos in the US here, especially where you never want to use it when it's friable. And it's just very invasive. And so, do you foresee a pathway anywhere? And I know the United States is very strong on blower door requirements, especially in our new construction. Our utility programs actually seem to be backing off of it mostly for existing homes. But especially for new construction, we have it in our codes. I know the rest of the world is a bit in a different place. Maybe Europe is better. But do you see anyone kind of saying, "Hey, maybe we could use this in the code," and then, of course, adoption by any of the green building standard bodies as sort of in lieu of a blower door test?
We'd love to do that, and we've had a lot of people
Mhm.
in the industry who
Mhm.
are saying that, ultrasonic testing really should be part of the codes.
Mhm.
Um, I think, sort of individual bodies might begin to recommend ultrasonic testing, but I think for it to be on a par with something like the blower door test, what we'll need to do is have a study involving hundreds of buildings, and
Yeah, more
we're
data.
on
Yeah.
we're on the lookout for funding opportunities for that, because that's quite a large endeavor, and it's going to require some people to work with to actually realize and gather all of that data. But if anybody is interested in that, then we'd love to explore that.
Yeah, and it's certainly a question I get all the time. People are asking about ResNet or FIAS or other bodies.
Mhm.
Can we submit these results ASTM?
Yeah.
Can we use these results instead of a blower door? Not yet, but I think it is such a powerful tool to prepare for the blower door and to diagnose after a blower door.
Yeah.
And the more people that are using it, and the more it gets out there, we kind of need both the kind of top down systematic study that Daniel's describing, but also the sort of the grassroots, just people using it more and more and becoming
Yeah.
more and more familiar with it, including the people that sit on these boards. As it becomes more familiar, I think we will get there.
Yeah. And I should say for the question that came in about lead, a reminder that blower door testing is mandatory here in the United States and Canada for lead, but outside of the US, it is an optional thing you can do for extra points. So this might be an opportunity to try to integrate that there through a lead interpretation. So anyone who's working on that can reach out to me, and I'm happy to facilitate that conversation. So, um, great. Well, I know there's some more questions here fairly in depth that we're going to send out. Do you want to spend some time taking a few more, or what would you like?
I'm going to have to
I
jump off now, but
Yeah.
yeah,
yeah, it's
I
been
have some time.
a
Yeah.
pleasure. So thanks everyone for listening today, and I'm sure we'll follow up with some of your questions as well if John can't answer them.
Yeah, thank you so
Yeah.
much, Daniel and your team, and Chloe and Faye behind the scenes there. And thank you, and have a good evening. So take care.
Thank you very
Yeah.
much. Thanks for having me.
Yeah.
Thanks, Daniel. I'll see about the technical questions for you.
Thanks. All right. Bye
Yeah.
bye, guys.
Yep.
So another question that came in, John, is they were saying we are there's a comment slash question. We often specify CFM 50 or CFM 75 because we measure those directly. Getting ELA depends on subsequently applied algorithms. Some leaks in buildings are going to be accessible with US testers without scaffolding, ladders, etc. So how does a person using US tester get a building CFM 50 without getting to every square foot or meter of thermal enclosure?
If I'm following that, the question is, how do you scan every square inch
Yeah, maybe.
of the building?
Yeah.
And the question and the answer is typically we don't. Typically, uh, you're starting with where you expect leaks to develop. Yeah. Now, and I said there's a lot of art as well as there is
Mm,
science to it. As you do this more and more, you understand windows,
mm,
doors, outlets, MEP penetrations, sill plates, the roof lines, ducting, et cetera. These are your typical culprits, so that's where you're typically going to focus. I will say though, as I said, you don't have to be right up against it with the wand. You can kind of do a scan as you walk into a building that will give you a little bit of activity in an area. And if you see that area is not something where you would have expected their activity to be, you will investigate further and figure out why that is, why you see some activity there, and you can pinpoint it pretty quickly. But it's not intended to do a every square foot scan of the building. It's certainly possible if you wanted to, but that's not the most effective use of the technology.
sure.
Yeah.
Um, the other question here was, I guess, and you kind of covered renovations at the end, but just looking at some of the upper floor and the roof and ceiling
Yeah.
penetrations, are you just sort of putting that up above it, or what are you doing there?
So yeah, so there's a couple related questions that come to that
Yeah.
answer. So placing it generally, if you're up higher, what do you
Mhm.
do? The drone we talked about is one possible answer.
Right.
Scaffolding is another. There is, I said,
Mhm.
it's a cone that's projected out. So if you're looking at a two-story building, if you can place it at the top of a 12-foot ladder, you typically are covering the top and bottom floor from one placement. You can also just have it up on a large pole. I mean, it's really versatile, as far as positioning it. If you want to be outside of the building, you can also be up on the roof, and you can just position it on a tripod pointing down onto the top of the roof, and then be inside the attic with the sensor. You can also flip that around, which I've done. Is you can put the generator on the floor in the attic facing up,
Mhm.
that's blanketing the underside of the roof, and then you can be up on the roof with the detector, listening for any sound that's coming out of the building through the roof. Um,
Mhm.
yeah, so you get
Mhm.
the more you work with it, the more you kind of develop these tricks. Yeah.
Yeah.
Mhm.
And I'm assuming in those studies, is the data shared, or to the extent, what is the algorithm shared? So the question is, what does the algorithm that converts the square millimeters of leakage into CFM 50 account for?
That was a very specific Daniel question.
Yeah,
It's
yeah.
not worth it.
We'll get
But
we'll
yeah,
answer it and send it out. So yeah, yeah.
yeah, okay, yeah,
That's okay if we don't want to get to it yet. So
yeah.
um the other one is well, I mean, and I guess I'm just curious when you see people setting this up in their business model, are you helping people kind of think through how to properly charge for it. Like someone who's doing a blower door test is going to say, well, if your home is this large or I'm going to charge you this fee, right? Have you seen anyone kind of think through what that would look like in their contracts?
Yeah, absolutely. And I'll also use this to just to jump on one question that's come in about pricing. The links are in the
Yeah.
chat, and if you just click through to Source 2050, I think the retail is about
Mhm.
9,000 for the top unit, and the this kind of
Mhm.
scaled down unit is for something.
Mhm.
Um, what
Mhm.
what we've heard a lot, especially more in the earlier days, was this technology is incredible. I would love to have it on my job site. I would hire somebody in a heartbeat to come do it for me. But me, general contractor or
Mhm.
whoever, I'm stuck in the situation where I can't pass the entire cost on to the customer, which is what
Mhm.
you typically want to do. Nor am I
Mhm.
confident enough
Mhm.
yet to carry that on as a capex, for the firm that we're going to recover over time. I'm kind of stuck between the two. How do I justify the cost? Um, but I think the answer to that question is already found in the question, which is you would hire somebody else to do it, so you can be that person that people could hire, right? There is
Mhm.
this demand as people learn about it more. They're not so sure of justifying the cost yet, but you hear this question over and over again. Man, if I could have somebody come and do this, I'd do it in a heartbeat. So I think we were getting more and more people that are doing this. They're setting up a business. They're hanging out a shingle. They're already offering consultation or lead consultation services, airtightness services. They're now also offering to do the scan as part of they already have thermal imaging or whatever else they're already offering. Now they've added this to the tools, to the services that they offer. I think that is a big market. We're
Yeah.
not currently renting them.
Mhm.
Daniel mentioned that we're thinking about putting kind of a network of who our
Yeah.
certified practitioners are that would be available to hire.
Yeah.
But we hear that question often enough that I often say, I know you're saying that you would hire. I think a lot of people, a lot of people would.
Yeah.
And so, but I also would say the other way to think about it is once you really are comfortable with it, I encourage people not to analogize it to the
Mhm.
blower door. The blower door is a sort of milestone that you have to prepare for, that's time consuming, that you
Mhm.
kind of build up to. It is literally just there. I mean, you set it up and you can run a whole test in 5 minutes. It's just something that you do throughout. And so you typically would say, in a new construction, you're doing the test when before the insulation goes up, when all your
Yeah.
membranes are terminated, you're taped in, you're going to run that test. You're doing it when the windows are installed, you're running the test. You're doing it when the MEP termination and MEP penetrations are sealed. There's sort
Yeah.
of moments along where you want to be pulling it out, and it's great to just have it on site and not be an appointment where you're hiring somebody and they have to come by and set up for it. It's just there. You're just using it
Right.
repeatedly throughout the
Mhm.
process. That's where I think the real value is.
Yeah.
So yeah,
No, and I agree because
yeah,
it's like it's always you do the blower door test and it's like a problem occurs and it's like why, right? What happened? And you're doing all this fact finding and investigation and sometimes it's a mystery, right?
yeah,
It's the door of mystery. We call it the door of truth, but some days it's the door of mystery.
yeah,
If you
yep,
can't figure out why it is, and then the finger pointing game comes out, and so we love that game.
right.
But
Especially
yeah.
when you got your smoke pencil and the smoke is disappearing behind
Mm.
wainscoting or behind a baseboard molding. You're like,
Yeah.
well, what's behind what's behind there? Like,
Yeah, yeah.
let's start pulling stuff back. Like
Yeah.
this gives
So
you a much more targeted answer. Yeah.
So you mentioned the renting and you don't do that, but imagine an entity who wants to buy this and rent it. I know there are, for-profit entities that will ship you out the thermal imaging and they show you how to use it in a video and then you send it back. I know what's really cool are libraries now, like here in Holland, Michigan, really driven by the city government. They got thermal imaging and some other investigative technologies you can rent. I think they were even discussing a blower door, though that might be for just the qualified individuals. But I could see something like this being at the library. You go to rent it, it gives you a video, and you give it back. Like what? I mean, do you disagree with that, I guess?
Making it available as like a rental tool from
Yeah,
a
yeah,
library. I think that's a great idea.
yeah.
I think it's
Mm,
it's
mm,
uh getting it out to getting it in more people's hands is just going to benefit more and more projects. So I think that's a great idea.
Well, and maybe I should ask the question, the durability of it. I mean, is it something that can be easily beat up? What is its lifespan? What is its warranty?
Yeah, I get the specifics. It's covered for a good, healthy, a couple of years on
Okay.
hardware and software, and you get free support. And if something goes wrong, they'll ship you a new one, really, really quickly. They're fantastic about support throughout. It's built to be rugged. I mean, these are built for job sites. I have one here that I've had for coming up on 3 years now. That's been all over conferences and job sites all over the country,
Mhm.
and it's still clicking along. So yeah, they're
Yeah.
they're 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 built for the industry.
There was a question is what is the repeatability of this? And seems like a big question. I guess I think of the studies that still need to be done, to make it scalable. But do you have any other thoughts on how you might want to answer a repeatability question?
I mean, it's definitely repeatable. I've kind of I've hit this from a couple of different angles, but I mean that's what's really really kind of revolutionary about it is you
Mm,
do the scan now, you have an image, right? You
mm,
see where the problems are.
mhm,
You then come back after the remediation work was done, and you do a second scan, you take a second image, and you do those measurements again,
mm,
and you've got a perfect before and after. So it's a perfect instrument for repeating. It's quick to set up.
mhm,
The whole thing is done in a matter of minutes, and you have a record. So you can go back and redo the same scan, time and time again until you get it right.
mhm.
Yeah.
There was a question. Apparently, there's some cheaper versions of this kind of technology floating around on the internet, as they always are with things. Can you just speak to why, somebody would want to, uh, I mean, and the saying goes, right? You pay for what you get, right? I always say that, I always remind
Yeah.
people of that, right? So I guess, can you speak to that a little bit?
I looked at this. It's got to be over a year ago. Someone flagged it for me, and I'm trying to
Mm,
remember. But it was a different order, totally different instrument. I think what it
mm,
was doing is
mm,
just scanning ambient
mm.
sound,
Yeah.
not quantifying it, not imaging it, and it wasn't reliable because there was no generator on the other side. It was just sort of a open air
Mm,
ultrasound measuring
mm,
tool or something like that. I'd have to go back to. I remember the Amazon listing. I mean, it was brought to my attention a few times, and I looked at it, and it's a totally different product.
Fair enough.
Someone asked
Go.
about duct testing before,
Yes.
and I mentioned this early on. I just want to say yes, so you can set up the generator inside the duct and seal it, right, and
Yeah.
then be on the outside, and then scanning for anywhere where this ultrasound is escaping the duct. So it's very effective that way.
So you would be testing it lengthwise though, because you'd really have to just sink it in where you can get it, right? Like, and you're coming, because obviously you couldn't just push it through the ductwork, right? What am I
No,
misthinking that here?
you'd have the generator inside the ductwork,
Right,
right? So the entire run of the duct is now has ultrasound bouncing through it, and
right.
you're in the building
Yeah.
listening if it's escaping anywhere.
Okay. And I suppose that's more on a new construction, more existing might be a little less accessible, right? Than
Yeah, if you
yeah.
can't get to the outside to hear it, yeah, it's
But you can't set it up behind the ductwork and then fire it that way, right? You know what I'm saying?
how do you mean behind?
So what I'm saying is, let's say you're in an existing home and you see the ductwork, right? And you set it up behind it, and then the ductwork is so it's behind, the work, and you're facing this way with that, so it doesn't have to go in the ductwork. Would that help at all?
Oh, just is it going from one side through both walls to the other side
Yeah,
of the
yeah,
duct?
yeah.
Yeah, that would work fine. You just need
Okay.
access to the other side. Yeah,
Right, right,
that's
right. Okay,
that's
fair enough.
yeah,
Yeah.
yep, yep.
Um, um, And um, some of the other questions in practicality, this is just a comment. Well, I think there was just to clarify what does this cost, and there was some discussion about how it costs different in different countries. So I don't know how much you can speak to the, outside of the United States, but
I'm not sure. That was a good Daniel question.
yeah,
How what it's being sold for in other
yeah,
markets. But I'm sure the link has been in the chat here
yeah,
a few times. But through Source 2050, I think 9,285
yeah.
is the airtight, and the just baseline Porta scanner is a little over $4,000.
Okay.
But they're available quickly. They ship pretty quickly.
Mm.
So usually you can have it in your hands within a week of placing the order, typically.
Yeah, great. Well, those are all the specific questions I see. So, thank you all for joining us, John. Thanks again for helping organize this, and bring them in. And where can people go to, I guess, learn more about the 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 ultrasonic technology, and then just, where they can find it?
Sure. Yeah. So it's available in North America through Source 2050 through the same link. You can also go to the Coltraco homepage, their website in the UK, where they've got all kinds of studies and other documentation about the products. You can also email me, John at source2050.com with any questions you want to follow up. I do offer, if you have kind of a team you want to pull together, if you're in the New York area and we can work something out, I'm happy to come out to a job site. If you're not, I can offer what I call like a virtual live demonstration where I kind of set up my camera over my shoulder. I'll just test the window here in my room, and set up everything, and you kind of watch me over my shoulder and kind of remote control me. Ask me to go back, repeat that step, reposition that. How did you do that? So you have kind of a virtual demonstration of the product before you actually purchase it. Happy to set that up. If you email me, we can schedule something.
Awesome.
Yeah.
John Knapp, Source 2050, thank you so much. Thank you all for joining us. We'll catch you next week in March. So goodbye. Take care.
Great. Thanks, everybody. Thank you, Brett.
Yep.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.